Hello friends, this is a lesson on solving systems of equations by graphing. We're going to learn three methods for what we call solving systems of equations, and the first one is by the method of graphing. This is what we call a system of equations when we're considering more than one, in this case linear equation, at the same time. We are looking to solve it, which means that we are looking for the to solve is going to mean to find the one XY combination that makes both equations true. And we'll also learn a couple of algebraic methods to do that. So if we can remember that solutions to linear equations are XY values that make the equation true. For example, if I know one point on, if I was to graph this, one point on this line would be the point 1, 1. So if I put in 1 for x and 1 for y, I would have 2 times 1 plus 2 times 1, that's 4. If I put, for example, x equals 3, that would be 2 times 3, which is 6. And then if I subtracted that 6, I would get negative 2. That means y would equal negative 1. So 3, negative 1 would be a solution to that equation. So every point on the line that represents this equation would be a solution to it. Now this other equation has its own set of solutions and points. For example, if I made x equals 7 and y equals 1, that would be 7 plus 3 times 1, or 7 plus 3, 10. But these two equations would form two different lines. And as a result, they would have many solutions, but they do have one in common, and that would be their point of intersection. That's what we're looking for, the point of intersection. Will be the solution. It'll be the one XY combination. To the system here. So it will be the one combination that will work for both. I'm going to erase this right here. Okay, so let's the first thing, let's start by kind of actually are going to treat these two equations separately. So we're going to graph them separately. So I'm going to turn the first equation into slope intercepts. I'm going to go 2x plus 2y equals 4. So I'm going to subtract 2x, subtract 2x, and I'll get 2y equals negative 2x plus 4 multiplied by 1/2. And I get y equals negative x plus 2. So the other equation, I'll do the same thing. And I'll subtract x, and I get 3y equals negative x plus 10. This one's not a great one. It has a y-intercept that isn't an integer, but we can deal with that. 10/3. So the first equation, let's go back to the first one and graph that. That has a y-intercept of 0, 2. And so that's right there. And a slope of negative 1, I can go down, instead of down 1 over 1, I went down 4, right 4, up 4, as long as I go the same up and over. And that would be that line. And Then the other equation, I'm going to have this awkward y-intercept of 0, 3 1/3, but we'll just be careful there. So that's right there. And then I'm going to go, I have a slope of negative 1/3, so I'm going to go down 1, right 3, up 1, left, up 1, left 3. And you can see that it actually, I can see where these are, two lines are going to meet. That you'll notice that they meet at this point of intersection right here of negative 2, 4. And let's see, let me write that in a little darker color, negative 2, 4. And if I'm right, that's our solution that should work in both equations. So let's try that. If I put in negative 2, 4 right here, I get negative 4 plus 2 times 4, that's 8. So negative 4 plus 8 is 4. And then I go negative 2 here plus 3 times 4. So that's negative 2 plus 12. That equals 10. So that is a good solution. All right. So that, again, the solution is the one common solution that both equations have. In this case, it's negative 2, 4. Okay, continuing with our exploration of solving systems of equations by graphing. So that just means finding the point of intersection when you graph two linear equations in the same coordinate plane. So trying to convert both of these equations to slope-intercept. Let's start with the first one, which is x plus 2y equals negative 4. I'm going to subtract x from both sides, and that will get me 2y equals negative x minus 4. I'm going to then multiply both sides by 1/2. You don't really want to divide by 2 because then you'd have to distribute the 2, which you could do, but it's a bit easier if you just use the reciprocal here. And so you get negative 1/2 x, and then you get negative 4 times 1/2, or 1/2 times negative 4 is negative 2. And if you want to, you can put your modified system up here, y equals negative 1/2 x minus 2. And then we'll do it for the other equation over here. Let's subtract x from both sides. And then I will have negative. Don't forget to bring down the negative with the 1/2 y. Right, this time so then I want to multiply both sides by negative 2. That's the reciprocal of negative 1/2. You distribute there. And that will get me, if I just go right over here, y equals positive 2x minus 12. Now, since I have on this one, sorry, writing the wrong thing down there. Since I have a minus 12 there as my y-intercept, I'm going to make every one of these equal to 2. So I can make sure I don't have to go off the graph to get that y-intercept in there. I'll leave the x-axis the same. So when you change your scale lever, make sure you show me. If you don't change your scale, like I'm not doing anything to the x-axis, so I'm leaving that alone. So let me graph the first equation in blue here. So the y-intercept is -2. I got to put that right there because again I'm going in twos. When I go down 1, I only want to go down a half, and over 2. Again, my x-axis is in ones, and then I'll draw the line for that. So there's that line. And I'll put the other in green. Again, -12 is 0, -12 is right there. I want to go up 2, which is just up 1, and over 1. So again, up 2 is just 1 notch on the vertical axis. And then I draw a line through that. And so we end up realizing that we have a point of intersection right here at 4, -4. That's our solution. And you want to mark that and very clearly state it. I think you'll be able to see here when I plug these in, if I make x equal to 4 plus 2 times -4, that equals -4. And if I make this 4 minus 1/2 of -4, that'll mean plus 2, and that'll equal 6. So the next problem I want to go over is the system you see there. And so let's start by converting to slope-intercept there. And so I'm going to take that first equation, which is 5x minus 4y equals 20. And I'm going to subtract 5x. And I get -4y equals -5x plus 20. I'm going to multiply both sides by -1/4 to clear that -4. And I get y equals positive 5/4x minus 5 for that equation. I take my other equation and solve for, get that into slope-intercept as well. All I need to do here is multiply by 1/4. And I get y equals 5/4 x plus 3. So let me graph both of those lines. So again, my system, this modified equation is y equals 5/4 x minus 5. And this is y equals 5/4 x plus 3. And so I'm gonna graph the first one, which is the 5/4 x minus 5. So I go to 0, -5, which is right there. And I'm going to go up 5 and over 4. And I will draw my line then. And then I graph the other line, which has a y-intercept at 0, 3, also going up 1, 2, 3, 4, 5, and over 4. So that line will look, I'm going to graph that line next. So what you end up seeing here is that these two lines in this system are parallel, so there is no solution when that happens. So we want to say no solution as the lines are parallel. So they don't have a point of intersection.